Everyone for joining us. Good morning and welcome to the second webinar in the U.S. National Distracted Driving Coalition's four-part series on telematics and technology. This webinar is being recorded and will be made available following the session. So whether you're joining us live or watching afterward, we're very grateful to have you with us. My name is Melissa Hamrick and I serve as the Executive Director of the Kiefer Foundation. I'm also a proud NDD Steering Committee member. It's truly a privilege to moderate the second webinar in our series. Today's webinar will focus on driver and occupant monitoring systems, including how these technologies are being used to detect distraction, fatigue, and impairment. We will also explore how this data can support safer drivers, inform interventions, and help shape the future of roadway safety. These tools are becoming increasingly important as we work collectively to better understand driver behavior and leverage innovation to reduce preventable tragedies on our roads. We are so fortunate to be joined today by two outstanding experts who bring both policy and research perspectives to this important conversation. First, we have JT Griffin, Principal of Griffin Strategies. JT brings more than 25 years of experience on Capitol Hill and in government relations with deep expertise in transportation policy and roadway safety. We are also honored to be joined by Aimee Cox, research scientist at the Insurance Institute for Highway Safety. Aimee's work focuses on distracted driving and driver behavior research, helping advance our understanding of how technology can improve safety outcomes. We encourage your engagement throughout this webinar. Please feel free to drop your questions into the chat at any time. If time allows, we will address questions live at the end of the session. However, if we are not able to get to your question today, we will be sure to follow up afterward. So with that, it's my pleasure to turn things over to our first speaker and begin today's discussion.
Well, thank you so much, Melissa. And I'm going to get right into it. I have a few slides to share, so I will try to get those up and moving here. Let's go ahead and get started. Uh, okay. And let's see if this works. Okay, is that I think this is the right
Perfect.
slide, right? Oh,
Yep.
perfect. Okay, we did it. We did a practice. Just want to make sure I had this going. Well, thank you so much, Melissa and Aimee and everyone for joining us today. Again, my name is JT Griffin. I work with Seeing Machines, and Seeing Machines is a global company working with driver monitoring and occupant protection or occupant monitoring. We use human factors to assess and to look at driver status and to try and make sure that everyone gets home safely. So with that, we are headquartered in Canberra, Australia. And again, we are a global company all over the world trying to improve road safety. A couple of issues that we work on and we look to solve. Um, Everything from driver distraction, driver fatigue. You'll notice in the third frame there, we are heavily involved in level 2 and level 3 driver assistance technology, and we'll talk about that in just a second as well. And we also work in the aviation space, working with air traffic controllers in simulators, and then also with um, I mentioned air traffic controllers, and then with pilots as well. A little bit about why this technology is so important. Um, Distracted driving, alcohol impaired driving, and drowsy driving are three things that I'm going to talk a little bit about today, but all remain the leading killers on the roads in the U.S. As you can see, and these are using NHTSA FARS data, drunk driving still kills over 12,000 people a year. Distracted driving is killing over 3,000 people a year. And then in another assessment from NHTSA, they determined that over 10,000 people are killed every year from distracted driving. And then drowsy driving or fatigue driving is still a problem at over 600 people killed every year. And together, if you look at this, there's over 16,000 people killed from these behavioral um, causes every single year. Um, we've looked at the potential benefits of using driver monitoring and how many lives could be saved every year from that. And a total of over 12,000 lives could be saved if we were to get driver monitoring in roughly 50% of all vehicles. And then if you look at a cost savings per driver, and I know the issue of affordability and things like driver insurance and things like that has been top of mind in the public today. You'll see that we could save over $164 billion in savings from this. Um, so all of that is to say, what is a driver monitoring system? Well, it's really designed to work with the driver. Um, and it's determined to, or its purpose is to determine the state of the driver and to work with other systems in the car. And we're going to talk about that a little in just a little bit and how driver monitoring fits in with ADAS features that are currently in most cars today. Driver monitoring has been categorized into two different categories. You have indirect systems that are using inputs such as touch, steering torque. So when the driver's hands are on the steering wheel and are their hands on the wheel? Are they engaged? Using things like lane keep or lane departure or abnormal braking or acceleration. Those are indirect systems. And then you have direct systems which directly measure the driver's engagement. So things like where you actually have a camera involved, and the camera is able to monitor the head, the eyes, the eyelids, and the facial movements of the driver in real time. And at Seeing Machines, we're using cameras to directly measure these things. So we are a direct measurement. Um, One of the easiest ways to show how the system works is to share a video of how the technology is used. So, as I mentioned, we're using a camera to monitor the eye and the facial movements, and we can do that with great accuracy. And so, let me go ahead and show you kind of what you're seeing here. So here you have a driver who is you can tell they're looking around and you're seeing really what the system is seeing. So you can see this driver has his sunglasses on. They're in a convertible with the top down. So this is really one of the most difficult scenarios for the system to detect. And so you can see, if you can see the line sort of pointing from the bridge of the nose, the system is detecting where the driver is looking. Are their eyes on the road? Are their eyes off the road? And one of the questions we always get is, can the system see through sunglasses? And as you can see here, with these sunglasses on, absolutely, the system can see through the sunglasses. And so it is very powerful in how it works and what it can see. So I want to go to the next slide, and I want to give another example. And this really is looking at two different scenarios. It's called the owl and the lizard is what they use in the human factors terms. But really, what they're doing is you'll see in the first video here, the driver is driving, and his head and his eyes are coming off the road, and he's looking down, in this case, at a phone. So you can see how the how that works and how they're distracted. And so the system is picking that up. We're determining and we're seeing that the eyes are off road, and the face glance is off road. And then if you look at the next one, you can tell. So the head largely remains focused straight ahead and at the road. And then you can see the eye glances are dipping down to where the phone is, being held below and where the steering wheel would be. So in that situation, the system is still able to detect, is the driver engaged or is the driver not engaged when it comes to distraction. So I want to also share a quick video that shows really where we're at right now, which is more of an occupant monitoring system. So, in this situation, what you're seeing a body measurements where the camera can tell the body position. You can see one driver is on a cell phone. You can clearly see where the eyes are the eye gaze is directed. Is it on the road? Is it off the road? We're able to tell if the driver is belted. In this case, you can see there's a driver smoking. That's also detected as well. And these are all inputs that are used to make determinations of how engaged are the driver. You can see there that the driver was yawning. So you can pick up things like, fatigue. And these are all inputs that go back to the vehicle that can then make a determination as to what the driver's state is. Are they distracted? Are they falling asleep? And then we recently in the fall announced that we can also detect impairment, including impairment from alcohol as well. So really, that, as I mentioned, it's part of a more complex and complete safety system within the vehicle, driver monitoring. And it really fits in well with your ADAS system. So if you think of things like automatic emergency braking, lane departure, um, electronic stability control, all of these things that are part of your ADAS system, and we will have another webinar on ADAS at a later date that'll also talk about, or we'll talk about how these different things work. But really, when you include driver monitoring or occupant monitoring as part of these other systems, it really lets the vehicle become significantly safer because the system understands how to react when the driver is either distracted or impaired or drowsy. Um, we're seeing significant impacts of European regulation on the Euro NCAP, and we're starting to see OEMs really embrace the safety aspects of driver monitoring. Um, Impairment detection and distraction and detection is maturing rapidly, and it is definitely something that we're seeing take off within the European automotive market because of the safety aspects of it. Here in the US, driver monitoring uptake is really driven, no pun intended, by driver assistance features. So if you think of systems like Ford's Blue Cruise or the General Motors Super Cruise, the hands-free type of driving systems that are really rolling out, and those are just two examples. You're starting to see those across the board with OEMs. Driver monitoring is used to alert the vehicle as to when the driver needs to engage and to take control of the car. So those are really important. It's a really important system for that. But it can also be used for safety, and that's what we're seeing in Europe. So that's really the dynamic there, and the difference is the Europeans are really looking at this as a safety system, and here in the US we're really looking at it as a driver assistance system. And we're going to talk in just a second about how regulation in the US represents a real opportunity for the global harmonization of these technologies. So, what we're seeing in Europe and then what we're seeing in the US, whether it's driver assistance or for safety, there's a real opportunity through current proposed regulations to try and um, bring these systems together. So I mentioned that I mentioned the regulatory aspect. So in Europe right now, driver monitoring is required in order to get full credit for the Euro NCAP safety rating systems. Um, in the US, what we're seeing is there were requirements as part of the IIJA or the infrastructure law that passed a few years ago. There are requirements for NHTSA to study driver monitoring as a safety system and to make recommendations when it comes to distraction on whether or not those systems should be regulated in order to save more lives. You're we're also seeing within that infrastructure law, there was a requirement for a rulemaking on impaired driving technology. And for those of you who have followed it, has sort of lumped these things together and created an ANPRM where they have taken comments, and this is something that's currently in the rulemaking process right now. Um, and then there are other, various bodies that act as regulatory agencies as well that are heavily looking at driver monitoring. So, for example, Consumer Reports and the Insurance Institute for Highway Safety have both really come up with recommendations for how to implement driver monitoring safely. In this past fall, the Insurance Institute announced that they're going to be rating future vehicles on impairment detection technology. So from Seeing Machines, from our perspective, we believe that we'll be able to have a system that will accurately detect impairment as well. So just to wrap a couple things up here real quickly, when it comes to privacy, that's one of the issues that we get asked quite a bit about because there is a camera in the vehicle. The camera is usually discreetly placed within the car. So in some instances, it will be right above the steering wheel column. In some instances, it can be in places like the rear view mirror of the car. Um, it should be noted that driver monitoring should be designed as a safety system or a driver assistance system. It should not be a data transfer system. So from our perspective, for using the system for safety, we don't need to collect any data. No data should leave the vehicle. It should all stay within the car. It should be for the driver to use how they like. Our system is using local processing, meaning it's not, or edge computing, which means it simply means it's not going to the cloud where somebody else could see that data. So the system, the simple way to think of it is the system, sees whether the driver is distracted, whether the driver is impaired, whether the driver is falling asleep, and it sends a signal back to the car for the car to take action. And that can be a whole host of things, but that's really up to the OEM to make that decision. Uh, but the bottom line from a privacy perspective is this the signal doesn't leave the car. Um, Seeing Machines driver and passenger identification technology relies on stored in vehicle facial biometric data. So it's not actually using photos or videos. It's all things that are in the vehicle, and it's closed loop, which means again that it doesn't leave the car unless it's physically removed. And I know we're kind of getting towards the end here. I want to just share, if you look at the image on the right where you see the dots on the screen on the woman's face, that's what the system is seeing. It is not seeing a video like you're watching me through right now here on a webcam or something like that. The technology doesn't work that way. It's using points on a it's an algorithm, and it uses points on a screen to make the determination of drowsiness, distraction, or impairment. So I think hopefully that's helpful for people to understand. And then just to wrap up, there are lots of factors that can influence driver behavior that driver monitor driver monitoring can detect. Distracted driving, which is what we're talking about here today, drowsy driving and fatigue, or impairment from alcohol or drugs or something else. All of those factors can really influence driver behavior. Regulation of interior sensing has really increased in the US or in the EU, and the US would benefit greatly by doing something similar here from a safety perspective. Advances in detection capability mean the challenge has now shifted toward choosing and implementing what are the appropriate interventions. What does the car do when it detects distraction, drowsiness, or impairment? And those are all policy questions. Those are not technology questions anymore. So we've solved the detection piece of that. Our system absolutely can accurately detect distraction, fatigue, and impairment. And we believe that increasing driver monitoring system usage in the US could save over 10,000 lives a year. So with that, I would like to say thank you, and I will pass it back to the team here.
Thank you so much, JT. That was so informative. I know I learned a ton in that. So please, everyone, feel free to share your questions in the chat. We'll definitely try to get to those at the end. Aimee, tossing it over to you. Thank you.
Sounds good. Thanks. Let me just get this shared. And if I could just get a quick check to make sure that you're seeing my slides.
Good to go.
Perfect. Thanks so much. All right. So again, I'm Aimee Cox, research scientist at the Insurance Institute for Highway Safety. We surveyed owners of Subarus equipped with driver focus to get their opinions of and experiences using it. Essentially, what do you like about it? What don't you like about it? Do you use it? Would you want it again? So driver focus is Subaru's branded name for their infrared camera-based driver attention or driver monitoring system. Theirs specifically detects signs of distraction and drowsiness. JT mentioned in his presentation that vehicles equipped with these driver assistance systems are equipped with similar systems in the US market, but most are designed to only work during that partial automation state. Subaru's system is one of a few that works during normal driving, and they were one of the first manufacturers to introduce it in the US market. So this gave us a large pool of owners who likely had a good deal of experience with the system to then share their insight into it. We know distraction and drowsiness occur outside of partial automation. As JT mentioned, thousands of fatalities a year could be prevented. So that was the motivator with this study. So we had about 3,500 participants, and we found that most were knowledgeable about the system. We asked participants to describe what the system does, and 70% gave an accurate description. We then showed an image of the icon that's displayed on the instrument cluster. 93% were familiar with that. And among those drivers, 77% said that they knew the status of the system based on the icon's appearance. We also asked drivers how or where they learned about the system. At the dealership at time of purchase was the most common response, followed by trial and error and from the owner's manual. So we felt pretty good about participants' knowledge about the system given these findings. Moving on to the use of the system. The first question we asked in this series was if drivers set up a driver profile. So a driver profile is a component of driver focus. The vehicle does an initial scan when it's turned on. If the drivers recognize their climate and audio preferences, and then seat and mirror positions are automatically set. We found 86% of our sample set that up. And then most who did said that their vehicle successfully recognizes them most or every time they turn it on, and they have the driver monitoring setting under their profile set on. We asked this because if they've set it off under their profile, that is the only way that setting is maintained. So in other words, if a driver does not have a profile set, the monitoring turns on with each ignition cycle. So we found that just 4% of our sample who set up a profile and then set the monitoring component off under their profile. So we asked these participants a couple follow-up questions as to why they permanently turned it off. Receiving too many alerts and finding the system annoying were the two most common responses. So this suggests that the drivers who turned it off could perhaps benefit most from it. But even with the small number of drivers who turned the system off permanently, among all drivers sampled, 86% use it most or every time they drive the vehicle. And then among the drivers who use it, use was slightly higher on high-speed roads than on low-speed roads. Moving on to the opinions of the system among drivers who use it, over 80% agreed that the system can accurately detect when they're looking at the forward roadway. Over 60% agreed that it encourages them to be a safer driver and helps them avoid distractions. And then over 40% agreed that driving is less stressful and that they look away from the forward roadway less with the system. About 1 in 5 of our sample who uses the system agreed that it has helped them avoid a crash. We also asked drivers, have you ever not gotten an alert when you could or should have? The most common response here was no. So in other words, it's not missing opportunities to alert drivers when they're distracted or drowsy. So the false perceived negative rate is low. Moving on to the experiences with distracted alerts, we asked drivers how many they received in the previous 30 days. Drivers were most likely to say many, so 10 or more, or 3 or fewer. We asked drivers if they've ever received alerts when they were not distracted. Most common response was sometimes, yes, that has happened. But we wanted to get a sense of if it at least rarely happened, what were the circumstances, what was going on when you received an alert but felt you were not distracted. Changing lanes was the most common response. This was really interesting to me because the system is designed so alerts are not given when the turn signal is on or when the vehicle's in reverse. And that was done strategically to allow for roadway related glances with being in reverse or changing lanes. So this suggests to me that drivers just aren't using their turn signal when they're changing lanes more than a system flaw. We've seen from observational studies that that's about half the population, so I suspect that's what's going on here. But then when you look at the other behaviors on the graph, with the exception of driving related scans, the others listed are all distracted secondary tasks. It's worth noting that even the driving related glances may warrant an alert if the eyes are leaving the forward roadway for too long. We know from naturalistic driving studies that 2 seconds is all it takes to significantly increase your near crash or crash risk. So really the purpose or the intent does not matter. But this really suggests to us that there's some misconceptions of what constitutes distracted driving that's then giving this sense that some of these alerts are false. But we also asked how often drivers were alerted when looking away from the forward roadway. Drivers who said most or every time, even sometimes looking away from the road, the system's really working as it's intended. But the people who said rarely or never looking away from the forward roadway and alerted, we kind of did the same thing to figure out what might be going on. Those would be the false positives that could reduce acceptance over time. So these were all situations or behaviors that the sensor might be occluded or unable to sense the driver's eyes or head, largely temporary, but adjusting in the seat was the most common response. Now, the experiences with the drowsy alerts. There are 3 alerts that escalate based on the degree of drowsiness detected, and the system starts with an initial take a break warning. It's paired with 1 beep. Most of our sample did not receive any of these initial drowsiness warnings, but of those who did, majority then received the second intense alert. And then among those drivers, the majority did not receive the most intense alert. That displays the message to stay alert and beeps continually until the system can detect the driver's eyes have opened. Most of our samples said that when they've been alerted due to being drowsy, they didn't really feel drowsy, but 12% were alerted when they were about to fall asleep. So certainly some value when it comes to these drowsiness alerts. The next couple slides here are showing the general opinions of the system among the entire sample. The responses for the entire sample are shown in blue. The regular system users, so this would be people who use it most or every time, are shown in gray. And then the drivers who use it sometimes, rarely, or never, shown in gold. Most of the sample agreed that the timing and the volume of the alerts were appropriate. At least 70% of the entire sample agreed with the statements at the bottom of this graph, including that they would want the system again. So even drivers who regularly use the system appear to see some value in it. You can see that the majority did agree that it's a good idea for some drivers, but much more so than it's a good idea for all drivers. And we hear anecdotally so often when studying human behavior, I'm not the problem, everyone else is the problem. I suspect that's playing out here a bit in these findings. So to wrap things up, We found most of our drivers sampled use the system and seemed to value it. A caveat to that is that this happened to be an older sample. It's not representative of the entire population. Older drivers drive distracted and drowsy, but they tend to do so less than younger drivers. So if they're engaging in these behaviors less, there could be triggering fewer alerts, which could result in higher acceptance of the system. We found a small percent of the drivers permanently turned it off. Again, it's possible that those could be the ones to benefit most from it. We've seen from different studies that haptic alerts tend to be more favorable to audible alerts, especially for circumstances that are seen as low threat. One thing to keep in mind, though, is that a haptic steering wheel alert would not suffice if the hands are not on the steering wheel. We found more distraction alerts than drowsy alerts, but there certainly appear to be some misconceptions about what should trigger an alert. And then finally, because other manufacturers do offer similar systems, we would suggest that they expand the functionality to at least give drivers the option to use it at all times. So thanks so much. That's all I have.
Awesome. Thank you to both of our speakers for leading us on such an important conversation. We did have a couple of questions come through that if everyone is able to stay, we'd love to answer them here. The first question is for JT, and it has to do with, says, Transport Canada has told MAD Canada that the tech regarding impairment is not mature enough at this point for the government to regulate. Do you feel that's a fair point of view?
I would disagree. I'd say it is mature enough to begin regulations. So I think a couple thoughts on that. One, on the topic of distracted driving, which is really what we were focused on today. Absolutely, you've already seen the EU regulate on distraction and fatigue. It's already part of Euro NCAP, so the system's already in use in Europe. It's regulated. New cars have to have it. I would say when it comes to impairment, what Seeing Machines and we have recommended is a roadmap whereby you start warning drivers when impairment is detected. So if impairment is detected, then you warn drivers, and then that would serve as the first part of what a regulation would be. And then you would progress. So as the technology evolves, the warning could become more severe, and depending on what that is, that could be anything from increasing the sensitivity of your ADAS system. So perhaps your car, the lane keep is much tighter. Automatic emergency braking is much more sensitive when the car knows that the driver is impaired. And then that could lead all the way up to where the car could actually, pull itself over or would not be able to start. I think one of the things that with my background, having worked on impairment detection for a long time, I think one of the things that we think about is we start at the end in mind. So, initially when alcohol detection was envisioned, it meant that when the driver gets in the vehicle, if the driver is impaired, the car won't start. And, sometimes technology doesn't work that way. Sometimes technology has to evolve. And I think with driver monitoring, it can absolutely detect impairment right now. And then the question becomes, what does the car do? So that's how we've approached that issue.
Great feedback. The next two questions are for Aimee. So Aimee, were driver survey participants all Subaru vehicle owners in the study?
Yes. In this case, we just wanted to get the opinions of the drivers who have experienced the system. So not only Subaru owners, but equipped with the system.
Okay, and on that note, what technology is powering the Subaru Focus?
The driver Focus specifically?
Possibly.
Okay.
So
it's a similar system to the images that are the videos that JT was showing. Theirs is an infrared camera, and so it's affixed above the instrument cluster, and it faces the driver.
Excellent. Well, I would like to take this time to thank all of you for joining us today, and thank you to our speakers for providing such wonderful information. Please visit nddc.org for future webinars. We do have 2 more coming up in this series. Those dates to be announced, but join our mailing list so you can stay informed. And thanks, everyone. I hope you have a wonderful day.
You.